Okay, so this is the continuation of 7.2. These are some additional examples. I've got two more equations with rational numbers with fractions in them that we're going to go ahead and solve. And then I've got one real-world situation with decimals that we can go ahead and solve. So if you went through the first set of notes and you wanted some additional examples, this is where you should be. If you went through the first already and then you just wanted to try these ones and see if you got them right, you can absolutely fast forward, use this as an answer key, see if you got them right. If you didn't, then I would encourage you to rewind and watch the steps. So let's go ahead here and look at our example number 3. We've got 1/7 k minus 6 equals 3/7 k plus 4. Now, step 1, the first thing we need to do here is we need to find the LCD. So least common denominator, which we're looking for, is multiples of our denominators. Now, you'll notice right away that these already have a common denominator of 7. So we don't have to find it. What we're going to do now is multiply both sides of the equation by our LCD. Our LCD is 7, right? Because they already have their lowest common denominator. So LCD equals 7. So that's done. Step 1, super easy, done for us already. Now we're going to multiply both sides of the equation by 7. So 7 times 1/7 k minus 6 equals 7 times 3/7 k plus 4. Okay, so I've got my least common denominator multiplied by both sides of the equation. The next step is to distribute. So I'm going to multiply that 7 by both terms inside the parentheses. So 7 over 1 times 1/7 k minus 7 times 6 equals 7 over 1, remember, because a whole number turns into that number over 1, times 3 over 7k plus 7 times 4. Okay, now I'm going to go ahead and simplify by cross-canceling, so I'm simplifying first. So looking for common factors diagonally. This is already as simple as it gets. 7 and 7 have a common factor of 7, so 7 goes into 7 once. These don't need to simplify, they're already whole numbers. Same thing here, looking for common factors to simplify. 1 and 3 do not have any, but 7 and 7 have a common factor of 7. So 7 divided by 7 is 1. 7 divided by 7 is 1. And then we don't need to do anything with our whole numbers. So I'm going to go ahead and rewrite that now. This is 1, right? 1 over 1. So 1 times 1 over 1k. So this is 1 times 1k minus 7 times 6, which is 42. And then I've got equals 1 over 1 times 3 over 1k, so times 3k, plus 7 times 4, which is 28. So I'm going to go ahead and rewrite this again, just to simplify it more. 1 times 1k is k minus 42 equals 1 times 3k, which is 3k, plus 28. All right, now I've got an equation that I just have to solve. So I solve by combining like terms. I put constants on one side, variables on the other, and I use inverse operations to do that. So I'm going to go ahead and move this constant, and it doesn't matter which one you start with. Ultimately, you should end up with the same solution. So this cancels out on this side, right? So this is gone. And I've got 42 minus 28. I have to borrow 3. So 12 minus 8 is 4. 3 minus, common error there. I just made a mistake. These are two negatives, so this is the same as adding a negative 28. So this is 0. 2 plus 8 is 10, right? So 0, carry the 1. 4, 5, 6, 7. So this is negative 70. So I've got k minus 70 equals 3k. Right? I've got to put my Variables on one side, I can't move this, I can't move this, so I've got to move my k. Positive k, so I need to subtract, so minus k. Now again, a common error that we make here is we see this and we're like, oh, well 3k minus k is 3. Remember, this is 3 times k, so this is 1, 2, 3 things you cannot separate, right? Minus one of them, so we cancel one of them out. This is now 2k. So I've got negative 70 equals 2k. I need to figure out how much each k is worth, right? It's 2 times something equals negative 70. So I'm going to divide, because that is the opposite of multiplication. Divide by 2, and divide this side by 2. So I have negative 45 equals k, and that would be my solution. K equals negative 45. Oh, wait, whoops, that's not right. That would be 90. 70 divided by 2 is negative 35 equals k. There we go. You guys got to see me make quite a few mistakes here. Common errors, I make them too. So the answer to that one would be negative 35 equals k. Go ahead, and we're moving on to the second one here. We've got 5/6 k plus 1 equals negative 1/2 y. I don't know why I said k. It's still in my mind. So 5/6 y plus 1 equals negative 1/2 y plus 4, 1/4. So the first thing I need to do is find a least common denominator, right? I do have different denominators here. I've got 3 different denominators. So I'm going to go ahead and find my LCD of 2, 4, and 6. So I'm going to list my multiples, right? 2, 4, 6, 8, 10, 12, 14, so on and so forth. 4, 8, 12, 16. I think I see one. Oh, maybe not yet. Yep. So then I've got 6, 12. So I can see in listing these that my lowest common denominator is going to be 12. So now that I have my LCD, I'm going to multiply both sides of my equation by my LCD and then distribute. So 6, sorry, not 6, our LCD is 12. So I'm going to multiply both sides of my equation by 12. So I've got 12 times 5/6 y plus 1 equals 12 times negative 1/2 y plus 1/4. Okay, I need to distribute that. So I'm going to multiply 12 by each of these terms inside the parentheses. I've got 12 over 1 times 5 over 6y plus 12 times 1 equals 12 over 1 times negative 1 over 2y plus 12 over 1 times 1/4. Okay, so it's distributed, and this is a lot of work, I understand that, but it does allow us to simplify, and then we don't have to simplify after. So I'm going to look for factors, common factors that will allow me to cross-cancel. 12 and 6 have a common factor of 6, so this 6 goes into 6 once, 6 goes into 12 twice. Don't need to simplify here. Looking for common factors, these are obviously as simple as it gets. 12 and 2 have a common factor of 2. 2 goes into 2 once. 2 goes into 12 6 times. And then moving on, looking for common factors, I've got 12 and 4. 4 is a factor of both. 4 goes into 4 once. 4 goes into 12 3 times. Okay, so now I'm going to go ahead and simplify. So I can see that these are both over 1, so like I did in this last one, I'm going to go ahead and just kind of work some of this out without having to write all of it down. So I've got 2 over 1 times 5 over 1y. I know that this is 2 and this is 5, so I've got 2 times 5y plus 12 times 1, which is 12, equals, these are both over 1, so I know that this is 6 times negative 1y, right? Don't forget that negative sign there. So I've got 6 times negative 1y, or just negative y. You could write that also. plus 3 over 1 times 1 over 1. So that would be just 3 times 1, which is 3. Now I've got an equation that I can solve by combining like terms. So 2 times 5 is 10y plus 12 equals 6 times negative 1y is negative 6y plus 3. Okay, so then I'm going to go ahead and solve by combining my like terms using inverse operations. I'm going to move this variable term first. Since it's negative here, I'm going to add 6y. That's going to cancel it out on this side. I got plus 6y. Right? So now I've got 16y, bring everything down that hasn't changed, plus 12 equals 3. Okay, I can't move this, so this is done, but I can move this. So I'm going to minus 12 from both sides. So I've got 16y equals, because this is gone, 3 minus 12, which is negative 9. Okay, so now I've got 16 times something equals negative 9. This is multiplication, so I'm going to divide. I ran out of room here, so I'm just going to go ahead and rewrite this over here. 16y equals negative 9. So I'm going to divide by 16. And I've got y equals negative 9 sixteenths. Can I simplify that? No. So I'm going to go ahead and leave this in this form. Could you convert it to a decimal? Yeah, you could convert it to a decimal. That would be fine. But you can also leave it in this fraction form, and that is the correct answer because that does not get any simpler. So the answer to example 4 is y equals 9/16. Now I understand these are pretty labor-intensive questions, but you got this. Just make sure you're following each step, showing all your work, and keeping it organized. So if you come in with a question, we can go over it and find your errors more easily if you do in fact have errors. Usually it's very simple, and you've seen me make some of these simple errors. Unfortunately, I've caught myself, but you've seen me make them. So we all make them. Just go ahead and make sure that we're able to find them by showing your work. So this last one that we're going to go over is we have a real-world situation. So the first thing we're going to have to do, we know from our experience, is pull out the equations, set the equations equal. So we've got Logan, who has 2 aquariums. One aquarium contains 1.3 cubic feet of water, and the other contains 1.9 cubic feet of water. The water in the larger aquarium weighs 37 and 44 hundredths of a pound, 37.44 pounds, more than the water in the smaller aquarium. Write an equation with a variable on both sides to represent the situation. Then find the weight of 1 cubic foot of water. So our rate of change is going to be our cubic feet of water, right? That's what we're trying to figure out. So this is going to be the number that has the x attached to it. So we've got one aquarium which has 1.3 cubic feet of water. So 1.3x. It is the smaller aquarium, right? Because 1.3 is smaller than 1.9. So it weighs 37 and 44 tenths pounds more than the other one. So 37.44 more than the larger aquarium. So I'm going to go ahead and add this to the weight of the smaller aquarium. And then the other aquarium is 1.9 cubic feet. So we knew that that was our variable because that's what we're looking to solve for, is the weight of 1 cubic foot of water. So that's where our variable goes. Okay, so now we have an equation with decimals. We are determining the largest base 10, right? Well, the smallest, right? The smallest one, but has the most spaces. So this one is tenths, this one is hundredths, this one is tenths. So hundredths is what we need to multiply it by because that has the most spaces behind the decimal, and we have to get rid of all of them. So we are multiplying both sides of the equation by our base 10 value of the smallest place value, right? So smallest place value is hundredths. So we're going to multiply both sides. So 100 times 1.3 x plus 37.44 equals 100 times 1.9x. Okay, so I'm going to distribute that to each term within the parentheses, which only really pertains to this side, right? So I've got 100 times 1.3x plus 100 times 37.44 equals 100 times 1.9x. Now, when I'm multiplying by a base 10, all I'm going to do is be moving the decimals. So I'm moving 2 spaces, right? 2 zeros, so 2 spaces. So this becomes 130x This is going to move 2 spots. So this becomes 3,744. So 130x plus 3,744 equals, moving 2 spots, 190x. Okay, and then I just solved by combining like terms. So I've got a positive here. I'm going to subtract 130x from both sides. Cancels out on this side. I've got 3,744 equals 190x minus 130x equals 60x. And now I need to figure out, I'm going to rewrite this over here, 3,744 equals 60x. I need to do, this is multiplication, right? So I need to divide by 60. Divide by 60. And I should get the value of 1 cubic foot of water, right? So 3,744 divided by 60, and I worked this out in advance because I knew it was going to be a lot, is 52.4 pounds. So 52.4 pounds is the weight of 62. Did it again. 62.4 pounds. So I would just write that out in a proper way since it is a word problem. 1 cubic foot of water weighs 64, oops, I'm getting my numbers backwards here, 62 and 4/10 pounds. And that would be my solution. So you've had a couple examples. If you still have questions, please bring them in. Please bring these questions in. We can go over them in class. We have time, so write down your questions. Bring them in. Hopefully this helped a little bit. That's it. So you should have the original notes on one side and then these additional examples if you needed them. These were optional on the other side of the notes. Bring in questions if you got them. I will see you in class.